general solution for the given matrix. So you are given for the given system. So given this system, which is written in vector x prime, first you need to find a minus lambda I. So what is A? Let's call this matrix A, then minus that with lambda I. That gives you this matrix. Let me go over it real quick. Okay. Right now, and then you are going to find the determinant of this matrix. Okay, so let me work across the row. I have -1 minus lambda times, okay, cover this row and this column. So -3/2 minus lambda times -1/2 minus lambda minus 3 times 1/4. Okay, and then minus -1 times 3/4 times -1/2 minus lambda minus 3 times 1/8. Okay, and then plus 0. Alright, now you're going to distribute this out and simplify it. So let me do it real quick here and set this equal to 0. Solve for lambda. I will get lambda equals -1, -1/2, and -3/2. So here's my eigenvalues. Now for each eigenvalue I will get an eigenvector for it, so let's do it. Take a look at the first case when lambda equals -1. Plug it into here. I will have, but the goal is to find the unknown, so I don't actually need to reduce it down to a base metric. Let's take a look at the first equation. That gives me -k2 equals 0. Very quickly I can get 0 for k2. Okay, I can get the value for k2, which is 0. Now if I use, because I know that if I reduce this down to a base metric I will get an infinite solution. So let's see if I use, okay, let's use this one. So if I use this equation, I have 1/8 k1 plus 1/4 k2 plus 1/2 k3 equals 0. Okay, let's see which one. Okay, so since k2 equals 0, so just ignore this one. Okay, solve for k1. Should I solve for k1? Okay, solve for k1. So multiply this by 8, I get k1 equals -4 k3. Choose k3 equals 1, then my k1 is -4. You can choose whatever value for k3 as long as it's not 0. Okay, so then my k1 vector is -4, 0, 1. Now you're going to do the same thing for k equals -1/2, or for lambda equals -1/2, and this matrix becomes, okay, again you would reduce this down to a base matrix to solve for the unknown, but instead of doing those matrices, I just take a look at this matrix and then solve for the unknowns if I can. For the first equation, if I use the first equation, I can get -1/2 k1 minus k2 equals 0. Solve for k2, I will get -1/2 k1. Okay, now if I use let's see, use second equation, so I have 3/4 k1 minus k2 plus 3k3 equals 0. Okay, and then let's see, so solve for k1. So first I'm going to multiply the whole row by 4 to get rid of fraction here. So I have 3k1 minus 4k2 plus 3k3 equals 0. Okay, k2 is -1/2 k1, so plug it into here. So okay, so 3 minus 2, which is k1, 1k1. So solve for k1, I got negative 3k3. Now if I choose k3 equals 1, let's use k, it's okay, choose k3 equals 1, then k1 is equals to negative 3, k2 is equal to positive 3 over 2, then my k2 vector k2 is negative 3, 3 over 2, 1. Okay, again, you are going to repeat this process one more time for lambda equals negative 3 halves. It's kind of lengthy here, but just follow me, we almost done. Okay, plug it into the matrix up here. You will get a new matrix which is 1, negative 1, 0. Let's see if I did it correctly. I have negative 1 plus 3 over 2. Yeah, this should be 1/2. Let me double check if I got this correctly. Oh, bad. After I check this matrix, I figure I got something wrong. So if I plug in lambda equals negative 1/2 into here, so I have negative 1/2 minus negative 1/2, that gives me 0 and not 1/2. Okay, so this should be 0. Okay, now this stay the same for this one. So since you don't have k3, let's ignore this one. So since you don't have k3, let's do k3 equals 1, k1 equals 2, then that gives me k2 equals negative 1, then my k2 vector is 2, negative 1, 1. Okay, now going back to this matrix augmented with 0. Okay, so let's see if I use this equation, I will have 1/2 k1 minus k2 equals 0. Solve for k2, I get 1/2 k1. Now use this, so 3 over 4 k1 plus 3k3 equals 0. Solve for k3, that gives me 3 over 4, let's see, 3 over 4 divided by 3, you got k3 equals negative 1/4 k1. Okay, now if I choose k1 equals 4, that gives me k3 equals negative 1, k2 equals 2, then my vector k3 is 4, 2, negative 1. Okay, then my final, it comes to final solution. Right, since you have 3 distinct eigenvalues for this one, your final solution will be written in this form: vector x equals c1 times k1, which is this one, times e to the lambda 1t. Lambda 1 is negative 1, so you have e to the negative t, plus c2 times k2. K2 is this, e to the lambda 2 t2. So lambda 2 is negative 1/2, so you have e to the negative 1/2 t, plus c3 k3 is this, e to the lambda 3 t, which is e to the negative 3/2 t. Okay, so here is your final answer. That's it.
If you find the video is helpful, feel free to give it a like, share, and subscribe to my channel in order to receive the most current videos. Don't forget to hit the bell so that you won't miss anything. I'll see you next time.